In this video we will write Terraform code for the same project, and we will write them in 3 different ways. Watch the video to find out which level you are playing at and what you can do to level up your skills writing infrastructure as code. My name is Carl Lindberg. I'm a Microsoft MVP with focus on infrastructure as code, and I have written a lot of infrastructure as code in my days. I've written Terraform, I've written Bicep, and I've read a lot of code. I've read pull requests, I've analyzed code. The structure of this video is we're gonna have a noob level, a mid level or intermediate level, and a pro level. Like I mentioned, create the same project. So I'm gonna take the noob level code, if you wish, and we're gonna turn it into mid level code, and then we're gonna do the final touches. It's gonna make it a pro level code, if you will. I want to preface this video though that if the code works for you and it does what you want and it makes it easy for you to work with Terraform and with Azure, and if even better, if it makes it easy for you and your co-workers to work together on code, then it doesn't really matter what level it is. It's not bad code. I just want to give you my opinion on certain different levels of Terraform, and you may agree, you may not agree. Either way, I hope you're gonna find the video interesting. But let's jump into our noob level, if you will, or our beginner level, if you want to call it that. And what you can see right off the bat is we have something that I see sometimes, which I don't really understand why this happens, but it is pretty popular some places to have different categories that represents different environments. So as you can see here, we can have a dev environment or a dev folder with a main.tf, and if we take a look at this file contains 2 resource groups, a storage account, a virtual network, 2 subnets, and a private endpoint. So I'm not even gonna touch any of this yet. I just want to show you the problem I see with this approach. And the problem I see with this approach is that if we go into the acceptance directory and we look at its main.tf, you see the exact same resources. 2 resource groups, 1 storage account, 1 virtual network, 2 subnets, and a private endpoint. And what do you know? We have the exact same in production. Obviously, we have the differences that in production we use PRD or prod in the naming convention, while in main.tf we use dev. And you could also see we have different ranges for our different networks because we don't want them to overlap. So you are manually inputting a range in dev, and then you're using a different range in acceptance and in prod, which that's totally fine. But like I mentioned, this is a lot of code duplication, a lot of copy paste. And if you make a change in dev, you have to remember to make the exact same change in acceptance and then in production. Otherwise, you may have environments looking completely different. So that's something we can fix quite easily, but I'm gonna wait to fix that. I'm gonna make sure that we address the other things in here first, and then I'm gonna show you what the mid-level step we can take in order to fix this. So we have a few more issues with this. First off, we have hard-coded values for a lot of things. So this one has to be updated for every main.tf that you create. You're also not using any string interpolation here, so everything is hard-coded to be called dev, and the SC in this case is a short location, but that's also hard-coded. So it's fine if everything is gonna always be that way, but you may have a dev environment where you're going to use another short location or another location entirely. And again, the location is also hard-coded, but you can't change this value in just one place and have it propagate across your configuration. You would have to go into each individual line of code here and change it manually. So you may have to change this like 5-6 times depending on your code base, your code size. So that's an issue I see. Another issue I see is we have a little bit of a problem here with the naming. So when you use Azure RM, usually the resource type is already included in the name. So Azure RM prefixes the provider we're using, and resource group is the name of the resource we are creating. So it's actually pretty redundant to use RG in the symbolic name here. So RG-storage. It's fine that you tell me that this resource group is for storage, but I don't need to know that it's called RG again, like I already understood as much. And we have the same problem here where we have a Azure RM virtual network, and then it's using the abbreviation VNet. Like again, that is redundant. To further illustrate this, I will leave a link to this in the description, but there is a resource on the internet called terraformbestpractices.com, and they go through a lot of things, for example the code structures, but I wanted to look at the naming conventions, and here they do a little bit of a similar thing. Like, you could have something called a route table, so in this example it's AWS, but in Azure we have route tables as well. It makes sense to say that it is an AWS route table and that it is public, like that's concise, because you could have 2 or 3 route tables and it could be an AWS route table internal or private, and then you also have this one called public. But here they illustrate the problem, like you already have route table in the name, so you don't need to put it there twice, basically. This concept is sometimes referred to as you wouldn't call your dog dog, you would give him a more descriptive name. Hopefully there's none of you out there who have a dog named Dog, but I wouldn't be surprised. So the next issue I see with this is that we have a storage account resource that is apparently called state storage. And this is something I learned when I started working with Terraform. And if you are like me, who came from working with Azure Bicep and transitioned more into Terraform, you are maybe not as used to working with state. And you learn how to deal with state, and one possibility is you can store state in Azure Storage. However, as I've learned the hard way, you should never have Terraform create or manage anything that has to do with the state. The state resources, whether that be the storage account and container or whatever it is, it should always be created outside of Terraform, or at least outside of the current working Terraform code base. Because if you're in a scenario where the code is broken, or where your state resources are broken, or any combination for that matter, you could find yourself in a situation where you're essentially locked out of your config. And that's not a situation we want to be in, so I wouldn't recommend to create any resources in Terraform that's going to be used to handle your state. And then we just have a little bit more the same. It's like the no string interpolations. This is not very dynamic, and again, like the naming, this is super common, and like I've done this myself. I'm not trashing on anyone. Like, these are things, the reason why I include them in the video and why I had the idea to put them at this level is because I've done them and I have realized or been taught not to do them. And so this is absolutely not trashing on anyone. This is just you don't need to put the symbolic name, doesn't need to contain the resource type in this case. It is different if we're working with AC API provider, for example, but that's another discussion. And then we have a private endpoint, and for some reason we are deviating from the naming convention. So if you're creating a private endpoint, you would usually prefix it with PE, but maybe that's more of a Azure fault and not so much a Terraform fault, I guess. Okay, but now I would like to take this code base and I would like to show you how we can transform it and essentially turn it into the intermediate or mid-level Terraform and just give it like a polish and upgrade. So what I would do first of all is we could just come down here and make a new main.tf, and we could grab the code that is in main.tf in the dev folder and just paste this here. And this is going to be the last time that we are gonna copy this chunk of code, if you will. So now that we have this, I want to grab all of these and just get rid of them. We don't need them. What we will do instead is we will create a new file inside a variables folder. We're gonna call this one dev.tfvars, and in addition to this we will also want to have an acceptance.tfvars, and then we want to have a prod.tfvars. So in here we're gonna make sure that we are gonna deploy things, and we're gonna keep main.tf the same for all environments, but we're gonna make use of the tfvars files for different input parameters. We also want to establish, like, we have to declare variables. Convention is that you put variable blocks inside a variables.tf, and you would put, if you have any output blocks, you would put them into an outputs.tf. So inside variables.tf, I know that we are going to want to use environment, and we can accept that. I am also going to use a variable called location. It likes to suggest default values for me for some reason, but I don't need it right now. So location short. So this one is going to be formatted as such. I don't care too much about the descriptions right now. I just want to get the variable blocks established. And now that we have that, we can go into dev and we can say the environment is dev. We can copy this and say that in acceptance.tf, I guess I didn't copy this. In acceptance.tf, we can have environment acceptance. And finally in production, we have environment production. And then I can hear you say you created 2 more variables where you're going to use them. Here's another convention for you. So if you have a variable that is that needs to be specific to a specific environment, you declare it inside the environment specific TF vars. You say for this example it's environment equals prod. So when we run against prod, we want to make sure that the environment actually equals prod and does not equal dev or ac. But we have a few variables that are going to be the same for all environments, no matter what environment we're deploying it to. And we can put them inside a common.tfvars. So these are variables that are shared between all environments. Perfect. So now to get these to actually do what we need them to do, is we can make use of string interpolation. So wherever it says dev here, for example, I'm just gonna mark all of these. And then we can say we want to have string interpolation. We actually want that, but let's do this in a controlled manner. I forgot we need to have a $sign. And then we do var.environment. And everywhere it says sc. Not that one. Here we want to say location short. Same goes for this one. We want that to be location short. And the next thing I'm actually going to do is, I told you we don't deal with state resources in Terraform, so I'm just going to remove this one to be fair. Same goes for the private endpoint. I don't need it since I don't have the storage account, so that just goes away. Then we have Sweden Central, so we want to make sure that we are using variables here as well, so we don't have to change this everywhere if we need to. And then we have some more environment specific inputs that we need to give it. So right now we're hard coding the address range for the virtual network and the subnets. And like I told you, we're only going to have one main.tf, and I can't have the same address space in all my environments because I'm going to have an IP conflict. But we can solve that pretty easily. We first just have to make sure that we define a few more variable blocks. So one would be virtual network address space. The type here is a list of strings. Then we do a variable and we do a app subnet address prefix. And we need one for our database. And we should be good citizens since I said this is a level up on the professionalism, so we need to add descriptions. All right, so if we just take this one, which is for dev, and we go into the dev.tfvars, we say virtual network address space. That's what I want. And then I want a app subnet address prefix. This one can be that's totally fine, and a database. So now we need to grab these. So we still do a little bit of copy paste every now and then. We don't hate too much on copy paste. Just want to make sure we update this to a new range so we don't have an IP conflict. And in production, we're gonna do the same. And then finally, we have to make sure that we actually use the variables. So here we want to use variable virtual network address space, app subnet address prefix for the app subnet, and the DB for DB. Okay, so to summarize, we got rid of all the environment-specific folders and we replaced them with environment-specific variable files instead. This allowed us to keep one main.tf with one set of this code instead of 3 copies of this code. Oh, I actually see. We should also make sure we don't name our dog. So we are going to update the names for our resource group. So storage and network is fine. Another convention is that if you only have one resource of this resource type, for example, we only have one virtual network, the convention is actually to call it just this. You don't have to make up a name for it. You can just call it this. But this means that we have to update our connections here. So we have to change the name to network here and here. And the VNet is also renamed this. I'm also aware of the fact that we are now not using a storage, or we're not using the storage resource group for anything, but I want to keep it for my next level example. So that's why it's going to remain. And this one should be app, and this one should be database. Because we have two different types of resources of the resource type subnet, and one is called app and one is called database. Just like how we had the example of a route table. Okay, so I would say that like only with this is a very good level to be at. This is, in my opinion, very functional and very well working code. Like you could notice, it didn't take too much. Like we reduced the amount of code we had to write drastically, and we also made sure that we're gonna have an identical environment as far as the main.tf goes. Now we want to move into the pro level. This is where you are the god of Terraform, the master of infrastructure as code, if you will. Or not, just stupid like I am, but anyways. So the theme sort of was avoid code duplication when we moved from noob to mid, and the theme from mid to pro is still more code, like still avoiding more code duplication. So right now we have, for example, Azure RM, we have 2 resource groups, and we have 2 different resource blocks for the same type of resource basically. So what we could do instead is we could create a locals or a variable, doesn't matter, but we could say this is a storage resource group list. I want this to be a list of strings. One is going to be called storage and one is going to be called network. Now that we have this, we can actually get rid of one entire resource block, and we can come into the first one and say just local, or for each to set local resource group list, and we have to change storage here at the end to each key. So each key in local.resource group list translates into storage and network. So this way we have one resource block for the resource group, but it's going to create 2 resources. And we probably should call it this now. And this still works across environments. So RG, var environment, var location short are still going to be updated when we move from dev to act to prod, or at least environment will. And then each key is just going to be the first iteration, it's going to be storage, and the second iteration is going to be network. But then we have a problem, right? Because now you could see this line of code here turned gray. And that's because a resource group name, Azure RM resource group network.name, it doesn't exist anymore. We removed it. And maybe you're wondering, how can I target the correct resource group? Because I don't want to create a virtual network twice. I just want to keep this as a single resource. But I also don't want to create it in the storage resource group. That wouldn't make any sense. And you would be correct. So there is a way we can target this. So first off, we have to say this because the symbolic name is still this. We have to target the correct key basically. You do that by open square bracket, just say network, and then we can do .name. And we do the same for .location. This is still gray, but it should work. And that's just VS Code being VS Code. The address space doesn't change here. And then if you are really vigilant, you may think, oh, he's going to do the same for the subnets. And yes, I will, but not entirely the same way, because we want to give it 2 different input values. Here, I'm just giving it 1 input value, storage, and then network. But for for subnets, I want to give it 2 input values. The first value should be the name, and the second value needs to be the address prefix, because we want to make sure that the app subnet address prefix is still attached to the app subnet, and vice versa with the database. And it's not too difficult. We could say subnets configuration, and we'll make this a map of objects where we can say that the first one is called app. The name here is still app subnet. And then we can have address prefixes and just add the variable here, address prefixes. And we want to be doing the same for DB. There you go. So what we do then is we are going to come down to subnets, and we're going to remove the one resource block that we don't need anymore. We're gonna make a new for each of local subnet configuration. Then for the name, we have to say each value.name, because remember each key is gonna be app and DB, but each value is still tied to its key. So app, which is the one key, then value name, and then you get the actual string. I felt like I explained that kind of poorly, but hopefully it makes sense. And then just each value address prefixes again. And Copilot is correct. We have to update the resource group name to make sure we are targeting the network resource group. And we don't have to do anything with a virtual network. Okay, so given from where we started with a bunch of code, now we are much more condensed. We have a little bit of logic, and it looks, in my opinion, a bit more sleek, but it is also functional. And yeah, I'm pretty content with this. And I just also want to mention a very important point is that maybe I'm giving off the impression here that more complex is cooler, or less code is cooler, or more functions are better. And if you are writing code that is in the end going to be too complex for you, or even worse, if it's too difficult for someone in your team to read and it's too difficult for them to understand it, then it would be the only scenario where I would actually say, yeah, this is bad code because you don't understand it, or perhaps you do, but your teammates don't understand it, and then it is bad code. So more complex and more fleek, or whatever you want to call it, is not always better. And if your teammates don't understand it, then it's downright bad. But these are just some tips that I've picked up from my full-time consultancy work and my research with just researching Terraform. And if you think this is interesting, I make more videos like this on my channel. You can just have a look. There's a lot of Azure, a lot of Terraform, a lot of this that you saw in the video. So if you find that stuff interesting, be sure to give this video a like and subscribe to my channel, and I will see you in the next one. So thank you and bye bye.